something like calories from the other ingredients. Right? This is total calories. It's like a nuanced difference, and you're probably on the right track, but calories from the other ingredients. Priya said neither 8 or 3 worked. I liked group 3 on their board, what I saw for that. I saw something like they substituted in 8 and saw that it does not equal 27. And they substituted in 3 for the number of carbohydrates and saw that also did not equal 27. So that means Priya is correct. So something like they don't equal 27. So finding the solution, I can tell you guys have done equations last year. All right. Do you guys remember that hanger diagram, keeping it balanced? You guys remember that? You take something off one side, you got to do the same to the other. So I'm going to subtract 5. And then divide by 4. This is my favorite way to write the answer, but you all probably wrote 5.5, eh? 5.5 is 11/2. I just like fractions and then simplifying. So how many different answers could we have for this equation, 4c plus 5 equals 27?
1, 2.
How many answers make it true?
1.
Right here, 1 or 2?
Oh,
2?
2. No.
Oh, so, okay, so Joe, I like what Joe's saying. You could write 2 different ways, but here's what I'm going to say, Joe. These are the same. They're the same. So it's still one answer, but that's good. I like that you were saying you could write it more than one way. We could also write it as the mixed number 2, right? Cool. I think we're going to be ready to roll for the next question then. The next question is Jada. She's going to start hustling. She wants to make some money. Okay, she wants to turn a new page in her life. She's going to work at a bookstore. Maybe it's I like Schuler books. $12.20 an hour, which seems pretty good. Oh, one sec. Okay. So she's getting $12.20 an hour to work here. But to get there, she has to ride the bus, and that costs $7.15. Your job is going to write an equation that represents her total earnings first. That's your first thing to do. And then you're going to see how many hours she needs to work if she gets a total of $90.45. But you'll also need to write an equation for that as well first, okay? You're going to test out some stuff on 3. And then on 4, you're going to use words to explain what the answer means in context, right? That's the whole point of getting an answer, is like, what does this mean in the situation? So let's get after Jada in the books. So looking around, most groups have an iteration of this equation where we know that she makes $12.20 an hour. And we have to take away bus fare because we're not making that money to get total earnings. A great way to know if your equation is working for the situation is if you can just read your equation and summarize your situation from your equation. I don't know if you've noticed, but I've been doing that the last few days every time I've had an equation. Because the equation is the situation, right? They're no different. It's like we're translating it to be math ready. So for problem number 2, we have additional information. We have a total earnings. So the only thing we need to change in the equation is the total earnings. So I've still got $12.20 an hour. I'm paying for a bus. But I know at the end of the day, Jada is taking away $90.45. Okay? Again, I could just read it and say the whole situation with my equation. So group 3, again, is the one that I saw do this. And then group 1 went and doctored it up a little bit to explain how we know if 4 or 7 work. Really what we're going to do is say, how much money does she make if she works for 4 hours? And then you actually don't even have to do the math. You could just estimate. If she works 4 hours, she's going to make $48.80. By the time she pays for a bus, there's no way she's going to be at, I put a decimal in the wrong spot here, 94, missed it, 90.45. If she works for 7 hours, right, to see if it equals 90.45. She's only earning like $84 here. That's not enough before she even pays for the bus. So I know that they both don't work. All right? Yeah. She won't make enough money. Okay, so what's good is we have one variable, so we can solve for that variable to get an answer that does work. And you did this a bunch last year. And I'm going to go back to this equation right here from number 2. So I also, when I'm solving equations, sometimes I like to think about what that means. When I add $7.15 to both sides, that's like how much money she like got from the business, right? Her $12.20 an hour is going to be $97.60. Right? The reason it's $90.45 later is because that's after she paid for her bus fare. Then we're going to divide by the price per hour. $97.56. And we get 8 hours.
Wait, really?
What gets important here is right here, when it says, what does the equation tell us? We're going to then put this in context. What this would mean, and I'm going to need some room somewhere. What this is going to mean is something like this. I'm going to write it up here. Yeah, I know. Hey, wait 1 second. Wait 1 second, guys. She earns $90.45 take home. That's right here. That's the important. Take home if she works 8 hours. That's what the answer means in context. That's the whole big deal. And the reason we have to mess with the bus fare is if the E is earnings, how much money she like ends up with at the end of the day. We have to mess with that bus fare.
But when you add it, doesn't she lose that?
Because she has to earn that much. She has to spend it, right? So like the business gives her that much money, and then she spends it, so her total earnings go down. She had to make that much money. This is like the business gave her this. And then she had to spend some on the bus, so her total earnings were down, right? She has to account for her expenditure to get there. Because the question is, how much money is she taking home at the end of the workday? Okay, so we have to account for the bus fare. So a good idea, again, is to always be able to state answers and what you're doing in context. That's the whole point of everything. There's one variable, so that means how many solutions are there? 1. There's only one number of hours where she leaves with the $90, whatever, with $9.45. 8 hours, that's it. There's no other way. Okay? So what we're going to look at next is what happens if there are 2 variables. Okay? So we're back to some nutrition stuff. There is 4 calories per gram of protein, 9 calories per gram of fat, for a total of 60 calories. Okay? Right here. You've got your equation. You're going to test out some combinations of protein and fat and see if it works. Just kind of like we did last time. Notice I said combinations, though. There isn't just one. And then you're going to see if you can figure out how many grams of protein if you know the fat on problem 2.
Okay.
And then you're going to use your words to explain things in context for problem 3. All right, so looking around, we saw a lot of good things happening. I like that the communication got a little better for problem number 1 after seeing a couple. I saw most groups doing this, something like 4 times 5 plus 9 times 2 equals 60. And what this says is 4 calories for each gram of protein, 5 grams of protein, plus 9 calories for 2 grams of fat, totaling 60 calories. And does that work? Well, is 20 plus 18 60? No, so that is not a solution. Again, I want you to notice I can say the equation, and the equation is my situation. Next, I'm going to try out 10.5 grams of protein and 2 grams of fat. Let's see if that equals 60.
It does.
How do you know?
42 plus 18.
42 plus 18 equals 60. So this works. 10 grams of protein, 2 grams of fat. And last, 8 grams of protein. All right. Then we have 4 grams of fat, and those are at 9 calories each. So I got 40 and a 36. Is that total 60? No. So that doesn't work. Next, let's see if 6 grams, is there a way that if we know that we have 6 grams of fat that we can get to work? Well, check out where I'm going to put 6. We'll put it right there because I know 6 grams of fat is going to give me 54 calories. If I subtract 54 from both sides, I know that 4 calories per each gram of protein needs to be 6. So I need 1.5 grams of protein in order for this to work. Okay? Now, if number 3 says, in this situation then, what does the solution mean? I want you to check this out. The solutions are always going to be an ordered pair. There's a combination. I kind of like that word even though it's not in the stuff. A combination of protein and fat that are going to make the equation true. We already know, is there only one answer? No, we know we had a combination of 10.5 and 2 that worked. We also now have a combination of 1.5 and 6 that work. How many combinations do you think work? Yeah, in theory, infinite if we could go out a lot of decimal places and stuff, right? So when we had one variable, there's one answer that worked with an equation. We have 2 variables, there's an unlimited number of combinations. Now, there's some combinations that won't work. What about a negative? Could I have a negative in this? Can we have negative grams of fat or negative grams of protein? No. So again, this tells us the combinations that work, we have infinite solutions, and we need both. If there's 2 variables, we need both. I want to look at something real quick with you. We can solve equations, but the solution, if there's 1 variable, how many solutions? 1. And we found all the some non-solutions too. If there's 2 variables, what's required?
More answers.
A combination of answers, and there's infinite of those, right? Those are the 2 big ideas. You guys are going to do the cool down. When it's done, I'll hand you the homework. The cool down's on the board. Back to your science seats, please.